Now this is part 3 of factoring a perfect square trinomial and the difference of squares. So let's look at some more examples, that are slightly a little more involved, but not too bad. Okay, so you get this expression, they're asking you to factor it, right? They're asking you to factor it, and you recognize, well, you see that this, okay, this is a binomial here and it's squared, and this is a binomial here and it's squared, and there's a minus there. Well, based on the lesson that we've been looking at so far, this is a this is a difference of squares, right? Because you can see that it follows this pattern over here, right? Except that, of course, now our a and b values are expressions, entire expressions, right? So our a expression is this one, 5c plus 3. That's our a. That's our a. And then our b would be 2c plus 1, right? That's our b. 2c plus 1. Alright, so if we recognize that, then we can simply answer this. Now, this may get kind of big, so you may want to give yourself some space. I will use the square brackets to separate these, right? So we're gonna have, what's our a expression? So a plus b, a minus b. So a would be 5c plus 3, right? We put this in brackets, plus, and our b expression would be 2c plus 1, right? We close this. And then we have our next expression, a minus b, 5c plus 3, and then we write minus 2c, our b expression, 2c plus 1, let's put that in brackets, and then let's write some big square brackets. And that's it. So we factor this expression, right? Okay, let's look at another example here. Right, let's look at another example here. 9x squared plus 8x plus 25. Alright, so as always, right, we look at all the terms. Is there a greatest common factor among all of them? No. Is it a simple or a complex trinomial? It's a complex trinomial. Alright, is it a perfect square or a difference of squares? Well, let's see, this is a perfect square and this is a perfect square. So let's see, let's do some investigation for the middle term. Well, this becomes 3x, right? 3x. If this was our a term, 3x, right? If this is our b term, this will be 5, okay? So since we're talking about perfect squares, then we're strictly speaking, we're following that pattern. If it is a perfect square trinomial, right? And we want to follow this pattern, not the second one. Why? Because, well, there's a plus there and there's a plus there, right? Okay, so far our a value is 3x, right? Our b value would be 5. Okay, so what would a 2ab value be? Well, if we multiply, right, 2 times 3x times 5, right, this becomes 3 times 2, 6 times 5, 30. 30x, right? We get 30x. So this is not, it doesn't match that. So this is not a perfect square trinomial. So we know that it's a complex trinomial. So what we do is basically we continue solving with our complex square trinomial. So we're looking for two numbers that multiplied will give us 9 times 25, which is 225. Right, and when we add these two numbers, we want to get 8, right? So I would invite you to try to do this. In fact, I invite you to pause the video right now and solve it, right? And then play it again. So pause it right now. Alright, so now that you've tried solving this, you've probably realized that it's been pretty difficult and hard to figure out using the normal methods that we've learned about factoring, right? Plus it doesn't follow this pattern as well. So, well, here's something that we use and we call the quadratic formula, but that will be in a future lesson. For now, I invite you to take this to graphsketch.com or Desmos calculator and graph it and see how this function looks like, and then maybe I want you to theorize as to why was it not possible to factor this.